What you just saw wasn't a movie. That is what happens every single time you hear anything. You hear my voice right now, but do you know what's actually happening? You have spent your entire life listening, but you have never seen what sound actually is. You've never seen the insane, invisible journey it takes from me to your brain. Today, we're changing that forever. We are going to follow one sound wave on the most epic journey you've ever seen. We're going to watch it be born right here, travel through the air, and go deep inside a human ear. It's gonna be insane. For the first time ever, we are going to see what sound looks like. This isn't just about hearing, we're literally hacking reality. So let's get started. Every single sound in the world, from a tiny whisper to a gigantic rocket launch, starts with one simple thing: a vibration. That's it. Look at this speaker. When I play a sound, this cone moves back and forth hundreds, sometimes thousands of times a second. That movement creates the sound wave. It squishes air molecules together into a high-pressure zone and then leaves behind an empty, low-pressure zone. This pattern is the secret code of sound. It's just like dropping a rock in a lake. That first push makes a ripple that travels outward. It's the same idea. The speaker pushes air molecules, which push the molecules next to them, which push the ones next to them. It's a massive chain reaction. But here's the crazy part. The air isn't flying across the room. It's just the energy that's moving. It's an invisible pressure wave, a ripple spreading through the air all around us. But how does this invisible wave work? And can we make it visible? Okay, this is the craziest challenge yet. Sound is invisible, right? Well, not anymore. Scientists have found some insane ways to see it. One of the coolest is called chematics. A scientist named Ernst Chladni figured this out over 200 years ago. He put sand on a metal plate and vibrated it with a violin bow. The sand exploded into these insane geometric patterns. The sand moves away from the vibrating parts and settles in the calm spots. Every single sound creates its own unique, incredible pattern, showing off the secret geometry of vibrations. This proves sound has a physical shape. But what about sound flying through the air? Scientists in Japan just built this crazy new tech using high-speed cameras, lasers, and AI to literally film sound waves moving through space. By using a special deep learning AI, they can cut out all the other visual junk and create a high-definition video of the sound itself. We can literally watch the pressure waves ripple out, just like our rock in the lake. Then, other scientists at MIT did something even crazier with a technique they call the visual microphone. They proved you could get audio from a completely silent video. They filmed the tiny, invisible vibrations on a potato chip bag from 15 feet away as someone talked. Just by looking at those tiny movements, they perfectly reconstructed what the person said. They've done it with aluminum foil, water, and even plant leaves. This is definitive proof. As our sound wave moves, it physically shakes the world around it, and the stuff it travels through changes everything. Sound has different speeds in different materials. It's fastest in solids, slower in liquids, and slowest in gases like air. That's because the closer the molecules are, the faster they can pass the vibration. That's also why there's no sound in space. There's nothing out there to carry the wave. So, our sound wave, born from a speaker, has now traveled across the room. It's bounced off everything, and finally arrived at its target, the human ear. And this is where things get insane. Your outer ear is basically a giant funnel. It catches the sound and shoots it down the ear canal until it hits the first checkpoint, a thin membrane called the eardrum. When our sound wave hits the eardrum, it starts vibrating at the exact same frequency as the sound. A low sound makes it vibrate slowly, and a high sound makes it vibrate incredibly fast. Your eardrum is turning air pressure into physical movement. But this vibration is super tiny. It's so small, it has to be made bigger. And to do that, your body built an insane little machine, the ossicles. This is a chain of the 3 smallest bones in your entire body: the hammer, the anvil, and the stirrup. The eardrum is connected to the hammer. When the eardrum moves, it pushes the hammer, which pushes the anvil, which pushes the stirrup. It's a crazy, microscopic chain reaction. This tiny machine makes the vibration about 20 times stronger before passing it on. Just stop and think about that. That ridiculously complex machine is inside your head working right now, turning the vibrations of my voice into something you get. It's absolutely unbelievable. If you think hacking reality to see invisible forces is awesome, hit that subscribe button right now. We're on a mission to visualize the craziest science in the world, and every single one of you who subscribes helps us do it. All right, our sound wave has been caught, turned into movement, and made 20 times stronger. Now it's time for the final boss, the cochlea. This thing is the ultimate prize in hearing. It looks just like a snail shell, and it's filled with liquid and has over 15,000 of these tiny little hair cells. When the stirrup bone pushes on the cochlea, it creates waves in the liquid, and those waves make the tiny hair cells bend. And this is the most important part of the entire video. This is the exact moment a physical vibration becomes a signal in your brain. As the hair cells bend, they open up tiny channels that create an electrical signal. The vibration is now electricity, and the cochlea is a genius. Hair cells at the entrance are for high-frequency sounds, while the ones at the very end get the low-frequency sounds, so your brain knows the pitch based on which hairs are moving. Loudness is all about how many hair cells are moving. These new electrical signals, which are now a perfect code for the original sound, blast along the auditory nerve. After going through a few checkpoints, they hit the finish line, the auditory cortex in your brain. This is where your brain actually hears. And your brain isn't just listening, it's a prediction machine. It's constantly guessing what sound is coming next based on everything you've ever heard. If a sound matches its prediction, it's processed easily. If it's a surprise sound, it gets your full attention. The brain analyzes everything, pitch, loudness, timing, and compares the signals from both your ears to figure out where a sound came from. It separates my voice from the noise in your room. Some research has even begun to identify the specific genes that create specialized neurons for different sound jobs. Some cells only react to sharp noises, others are built to detect changes in speech or music. Your brain takes all this information, and in one final, insane calculation, it turns that electrical data into a real experience. A simple vibration becomes a voice, a song, or a warning. So, that was the epic journey of sound. It started as a simple vibration. It became an invisible wave. That wave made your eardrum vibrate, which moved the 3 smallest bones in your body, which created waves in a snail-shaped tube in your ear, which then became electricity that your brain could understand. This happened so fast you don't even notice it. But we just showed you the entire secret journey, this hidden world of physics and biology that lets you hear. It shows how insane the system is, and why you have to protect your hearing. We wanted to see what sound looks like, but we found something way crazier. We saw how an invisible force of nature literally becomes a part of who you are.